So in this last example for solving trig equations, we want to look at a different method that we can use, and that is squaring both sides of the equation so that we can use a Pythagorean identity. So in this case, we have tangent x plus square root of 3 equals secant x. And we're asked to solve over the interval from 0 to 2 pi, so we're working in radians. Now, if we think about the algebra again, and I always encourage you to go back to the algebra and think about the problem, and we think about tangent x as being x, and secant x as being like y. We have a little bit of a problem here once again because we have two variables, but we only have one equation. And it would be great if we could only work in one variable. If we bring everything over to one side and try to factor, nothing's going to factor. So our option here then is to use identities. However, the problem is when we look at our equation, I don't have tangent squared, and I'm looking for a relationship between tangent and secant, and the only relationship that we might be able to think of would be that Pythagorean identity. But the Pythagorean identity is only going to work if we have tangent squared or secant squared. So in order to make this happen, we would want to square both sides of the equation. Remember that we're allowed to do this because whatever I do to one side, as long as I do the same thing to the other side, we will have an equivalent solution for x. Now be careful, when you square both sides, it's tangent x plus square root of 3 times itself. So tangent x plus the square root of 3. So be really careful when you square that two-term side of the equation. Equals, now the other side, when we square secant x, we just get that one term, secant squared x. So over here we need to FOIL though. Tangent x times tangent x, I get tangent squared x. Outer times the outer, I get plus square root of 3 tangent x. Inner times the inner, plus square root of 3 times tangent x. And last times the last, square root of 3 times the square root of 3. That would be the square root of 9. And then let's simplify as much as we can. Here we have tangent squared x, no like terms there. Square root of 3 tangent x plus square root of 3 tangent x, that would be plus 2 square root of 3 times tangent x. And then the square root of 9, of course, is 3. Now, when we look at our equation, we see that we still have a situation that we have two different trig functions and only one equation, and we only want to have one type of trig function. Now we have the tangent squared x and we have the secant squared x. Which trig function should I want throughout my equation? Well, since we have this tangent x that's not squared, it would be really nice if we had the entire equation in terms of tangent. Because this tangent x is not being squared, it's not going to go away. So if I had everything in terms of tangent, then my equation would be only in one trig function. So let's replace secant x with an equivalent expression using our Pythagorean identity for tangent and secant. So that would be tangent squared x plus 1 is equal to secant squared x. So let's replace secant squared x with tangent squared x plus 1. Okay, so now this is the equation that we want to solve. And we have everything only in terms of tangent, which is what we were looking for. Okay, so we're going to bring everything over to one side, and then we're going to factor. So we're going to subtract tangent squared x and minus 1 from both sides. Everything's gone from this side. Now we have equals 0. And over here, well, the tangent squared x's cancel each other out, so we're left with 2 square root of 3 tangent x, and then 3 minus 1 gives us positive 2. So it simplifies to be something really nice. And then, of course, we want to solve for tangent x, so we'll subtract 2 from both sides. 2 square root of 3 tangent x. So we don't need to factor anymore because we lost that square term. So we're just going to solve this linear equation, or linear form of the equation. Divide both sides by 2 square root of 3. So you get tangent x is equal to, and we're going to cancel our common factors here. So we get 2 divided by 2, that gives negative 1 divided by the square root of 3. And now we're looking for the solutions here. A tangent is negative, so we're looking in quadrants 4 and quadrant 2. And remember that tangent is y over x. And before we go and rationalize it, let's think about what 2 points would simplify to be 1 divided by the square root of 3. And on the unit circle, we either have 1/2 or square root of 3 divided by 2. So let's think about this as being like a negative 1/2 divided by square root of 3 over 2. So what angle family are we talking about? Well, we need a y value of 1/2 and an x value of square root of 3 over 2. So it looks like our pi over 6 family, or our 30-degree reference angle family. And we were originally working in radians, so let's use the radian values. So that would be 5 pi over 6 or 11 pi over 6. Now, one of the things that we have to be careful about is that we want to make sure that we check both solutions in the original equation. So when we square both sides, we have to be careful that we check our solutions. Sometimes squaring both sides gives us solutions that don't work in the original equations. So we're going to go back to the original equation and we're going to check both of these solutions. Alright, so here's our original equation from the top of the page. We have tangent x plus square root of 3 equals secant x, and this is what we were originally asked to solve. So we want to check these two solutions, 5 pi over 6 and 11 pi over 6 in the original equation. So let's go for 5 pi over 6 first. Let's check that. So that's tangent of 5 pi over 6 plus the square root of 3 equals the secant value of 5 pi over 6. So if we go back and we look at our unit circle, so let's shrink this down a little bit. 5 pi over 6, the tangent value of that was negative 1 over the square root of 3, or square root of 3 over 3. And that was a negative value. So let's go ahead and rationalize that. Instead of writing it as 1 over the square root of 3, let's write it as negative square root of 3 over 3 plus the square root of 3 equals the secant value of 5 pi over 6. If we go up to the top, the secant value, of course, would be the reciprocal of the cosine value. So that would be negative 2 divided by the square root of 3. So does this add up to give us what we want? And let's see. So we would need to give them both the same denominator here. So when I add these two sides together, that would be LCD of 3. So if I multiply the bottom by 3, I got to multiply the top by 3 as well. And when we add these two together, we get 2 square root of 3 over 3. And notice that that is a positive value. On this side, if I was to rationalize to make both sides look equivalent, we would get still negative 2 square root of 3 over 3. And these are obviously not equal to each other. They are different by a sign. So that's what happens when we square both sides. It makes both sides appear to be positive after we square them, and then we solve the equation. We want to make sure that we check in the original before we do any squaring at all, when both sides could have potentially turned out to have opposite signs. So 5 pi over 6 is actually not a true solution, so we're not going to include that on our answer line. Let's check the other one, the other solution, 11 pi over 6. So tangent of 11 pi over 6 plus the square root of 3 equals secant of 11 pi over 6. So 11 pi over 6 has a tangent value of negative square root of 3 over 3 plus square root of 3 equals, now the secant value here in quadrant 4 is positive. So that is the reciprocal of the cosine value, so that would be 2 positive 2's divided by the square root of 3. And here, if we add the two fractions on the left-hand side, think about that as over 1, and give them both the same LCD, that would be 3. So on the left-hand side, we get positive 2 divided by the square root of 3 over 3. And on the right-hand side, if we were to come in and rationalize, we would get also positive 2 square root of 3 over 3. So this works out. They're both positive values. They turn out to be exactly the same on both sides of our equation. So we're going to keep 11 pi over 6 as our only true solution for this equation. So be careful, if you square both sides of an equation, make sure that you check your answers in the original to make sure that both sides actually do balance out using that specific angle.